This is the second class, the second session on yeah, just and there are two goals today. Obviously, all our problems we will be using the same strategy, okay, of Pigeonhole Principle. But there will be two goals. One is to do maybe harder versions of last day, and second should be to prove some theorems, to see the usefulness of this result of the strategy of this Pigeonhole Principle in showing that there are too many things and too few space or too few number of boxes, and so some things repeat and some things like that. Some periodicity comes or repetition comes, or some things come close to each other. All manifestations of that. To use these to not just solve some problems, but also solve problems which themselves will be used to solve other problems. Okay, that is proving theorems. So in that process, I might have to introduce some more language to ease the discussion, but this is the goal. So then with this in mind, let us begin. Let us begin with problem number 1. Problem 1, this is rather simple. Given, let's say, this set S, now I'll be framing the problems in a slightly more abstract way, and you guys should get used to it. Let's see. So we are given this set S, so 1 to 100. Pick any 51 numbers. You want to show that there are 2 co-prime numbers. Among the ones which we picked. So this thing should not be difficult. Co-prime. Co-prime, can anybody define co-prime for me? Right. Okay. So co-prime means that. So no, that's slightly incorrect. So, or if you want to expand on that. So X and Y co-prime means that the GCD is 1. There is no co-prime. So you're on the, Ishan, what you've said is, I feel is slightly incorrect, but let's see. So you are saying that any 2 consecutive numbers are co-prime, which is an obvious statement. Yeah. Any 2. Does everybody see this? I suppose. If not, then just tell me. Any 2 consecutive numbers. Yes, the reverse is not true. Obviously, all of us know prime numbers you can take it. So if any 2 consecutive numbers are co-prime, so then how do you use this? Yes, right. So from last time, this is a very simple question. Just so from last time, 2 of them will be consecutive. So this is like a special case of that, right? Because consecutive obviously implies co-prime. 2 of them are consecutive. and hence coprime. Okay. So coprime numbers are the ones which have the smallest possible GCD, right? Pair of numbers with the smallest possible GCD. Now we want to, this was just a, yeah? Now we want to prove the opposite of this. So what is the opposite of coprime? Just, it's a vague question, but what's the opposite of coprime? X is coprime to Y, what's the opposite of that? Hmm? Composite, but yeah, but they are coprime. So coprime is not, doesn't have to do with primes in that way, but so the opposite of coprime would be that one divides the other. Is that right? Yeah, because if one divides the other, then you get the maximum possible GCD. Is that right? Because if X divides Y, this means that the GCD of X and Y is X, given X is less than Y. Okay? This is the maximum possible GCD, right? We want to prove this. So what we want to prove is that the opposite is also true. There exist two numbers, uh, X and Y, such that X divides Y. Let's see if this is correct even. I think this is correct. Otherwise, you can give me a counter example. You can construct one numbers such that they don't divide. No pair of numbers divide the other. There is no pair in which one divides the other. Is the question clear? You're saying that you pick 51 numbers, but you will end up picking two numbers which will divide such that one smaller one will divide the larger one. Let's finish this. So yeah, Pragadish, so this is kind of problem number 2, but yeah, let's start with this problem. So it is similar in construction as the previous last day's first problem. You have 100 numbers. If you're picking 51 from them, so one more than half, you want to show that there will be two of them such that one divides the other. In fact, something more better is true. You don't have to pick 51, but let's do this. Any ideas? So here is a hint, because this is a slightly tricky question. how do you show that two things divide the other is a slightly tricky question. So just how we are going to represent, how we are going to think of the numbers is like this. This is, I think, a good way. We are going to think of the numbers like this. Any number n, we are going to think of it as the even part, its even part times its odd part. It may not have an even part, even the even part is not there, but we are going to think of its even part means the power of 2 that it has. So we're going to think of it as 2 to the power something, times the odd part. Means we're going to pull out all the even part and then the rest will be odd. We're going to think of numbers like this. For example, sorry, if you have the number 18, then that's 2 times 9. Right? Okay, this is, yes, if you have the number 36, then that's 2 square times 9. We don't have to factorize the odd part, okay, but we're just going to look at it like this. So this is the way in which we're going to think of the numbers like this and try to show that there will be 2 of them which divide, the one divides the other. Some other number, let's say this is x. Similarly, you have the y. We want to show that 2 of them among the 51 will divide.